What's going on, everyone? I am Dustin Stelzer with Electrician U. Today we're going to talk about some different ways that electricians might have to cut into metal. So if we have conduit that we're running in and we have a metal box and we need to get our conduit attached to this metal box, how do we do that? And there's a couple of different ways. So recently Milwaukee reached out to me and they've got this program called Milwaukee Grid. It's basically for apprentices. It's kind of like a pool of resources specifically for apprentices. They've got a whole bunch of different like videos and stuff from different trades. So if you're brand new to an apprenticeship, they wanted a place to kind of like help apprentices transition into their apprenticeship. So they do a lot of like giveaways, promotions. There's videos on how to use tools. There's stuff like this where I blabber at you about specific topics. So today's topic, we're going to be talking about knockout sets and how we address the issue of knocking out metal using tools out in the field. All right, so say that we are at some commercial building somewhere and we have a metal box and we've got a couple of different sizes of conduit that we have to run into this large junction box. There are some junction boxes that you can buy that actually have knockouts on them, and all you got to do is just hit the little circle and the disc pops out and you can just put conduit in. But most of the time, if you're talking about large junction boxes, large conduit, that's not going to be the case. You're going to actually have to tap your own holes in them. So how do you do that? There's a couple of different ways that are very messy and really crappy, but then there's just kind of like the tried and true ways that we actually use out in the field. You could use a carbide hole saw bit. But the problem is you're probably going to burn through those brake pilot bits, burn through drills. There's all kinds of reasons why you wouldn't use actual carbide hole saws for something like this. So what we do is we have a thing called a knockout set. And a knockout set is essentially a cutting die and a little metal cup that fit into each other. And when you either hand crank or squeeze a pump or pull a trigger, the die goes into the cup and it actually cuts out a round hole. And then you release it, pull it out, and you just keep going down the line. So today we're going to talk about the 3 different kinds of knockout sets that there are out on the market and show how they work and what the differences are between them. This is just using a hand knockout set. So hand knockout set's going to come with a handle, it's going to come with a bolt, and it's going to come with a bunch of different sizes. This goes from 1/2 inch up to 2 inch. So it's kind of an electrician sized knockout set. So the idea here is, say we're going to do 1.5 inches. This knockout, the cutting edge goes on one side of the metal and the cup goes on the other side, and they pinch together to cut through the material. So all of the knockout sets we're talking about, that's the whole idea. The bolt goes in, oops, goes the other way, sorry. The bolt will go through this side, and then this will go on the other side, and by twisting this bolt, we actually kind of ratchet the cutting edge inward, and that's how it cuts material. So the first one we're going to do is just to show how much of a pain in the butt it is for a hand knockout set. Granted, this is what I've done the majority of my career. I haven't had any like fancy stuff, but there are new things that are being developed, and we will get into that here in a second. All right, so one thing to discuss is you have to get a hole, a preliminary hole in the material first. That way you can put this bolt through. So we have to get a 1/2 inch hole in the material for us to do any of these. So there's a couple of different ways that you can do that. Typically, this is what a stepped bit is for. We call this a unibit or a stepped bit. But what this does, this will drill a hole and continue drilling a hole and get bigger and bigger and bigger. Now you'll notice using these, I'm just going to make a hole up here. It can take a while to get through.
So after continued use of these, they actually are really terrible. These are expensive, but if you don't take care of the tip, and if you drill at high speed like I was just doing, you're gonna end up burning these things up. So what a lot of people will do is they will start a pilot hole first, and they'll get a pilot hole drilled through. Then all they have to do is push through, and this thing will just keep chewing a hole. So it's got certain kind of steps on it. You know, like this would be for our 1/2-inch conduit, 3-inch conduit, and 1-inch conduit. But that's the idea of the stepped bit. The benefit, or the crappy thing about a step bit, is these little shards of metal are like molten hot. So when you're doing this above your head, you end up raining down shards of hot metal on yourself. So it's actually a very bad solution. There's another kind of unibit, and unfortunately I just don't have mine, but that goes on an impact driver, and it looks a little bit different, but it snaps in here, and due to the nature of this being an impact, you don't have to go at high speed to hold it and like send molten hot metal everywhere. You can actually go really slow, and it does the same kind of thing. So the other option that I think is a very good option is getting a set of carbide knockouts. So this is carbide, meaning it's really, really stout, but it already has a pilot bit on it that helps start drill the hole, and then it cuts out a disc. Rather than trying to clear material out and shooting all of that material outward to get rid of it, it just cuts a disc. So watch this. So it keeps most of the material right here. Now you did see around the edges it does shoot out. I'm not gonna lie to you. Either one of these, you're still gonna be shooting out really hot shards of metal. So it's a good idea to not be doing this like with short sleeves on, especially when you're working above. When you're above the material, it's not as bad, but when you're below the material and it's falling on top of you, you're gonna have little burn marks all over your skin. So be really careful about that. But I just like using these carbide things because it's just less. There's a lot less metal that comes off on you. Plus, it just cuts really quickly because it's carbide. So let's start cutting one of these. The first thing that I'm gonna do is I'm gonna do 1.5 inches. So I know, let me grab my stuff here. So I know I've got to get 1.5 inches male adapter through here. So what I need to do is find the exact center of that. And normally you kind of just have to eyeball it. A lot of people will do this. You know, if you don't have a whole bunch of these to line up and you're trying to make them really pretty and all in a line, then you don't really have to worry about measuring them. But a lot of times what I'll do is I'll at least just get that drawn out, and then I'll figure out where the halfway point is. So I know that from there to there is 2 inches. It's 1.5 inches hole, but it's a 2-inch hole that it's going to dig for this 1.5 inch male adapter to go in. That'll make sense here in a minute. But if you go right here, that's the center. Then do the same thing. A lot of people might ask, like, why are you not going from the end of the tape measure? And it's because the tape measure actually moves. So I always start at a line. That's how I take measurements. Anyway, so now I have the dead exact center of this hole, which will become important. And the other thing that I do too is, since this bolt is really small, I mean, it's about 1/2 inch, maybe a little bit more than 1/2 inch. This is a 7/8 bit, so I don't want to drill like a huge hole, you know, so like I don't want to have a huge hole for this thing to start moving around a lot. Otherwise I'll lose accuracy on my hole. So what I'm going to do is just pop this out. And then we've got our 1.5 inch. It says 1.5 inch conduit. It's not 1.5 inch on your hole, it's just, this is for 1.5 inch conduit. So you stick this in there. And on the other side, oops, dummy. On the other side, put this on. You don't want to leave a gap in there. You want it to go all the way to the top. Make sure that there's no slack. Now, you take this thing and it ratchets. Notice there's an on direction and an off. Just like any other socket set, there's one direction where it releases and clicks, and one where it actually draws and drives while you're pulling leverage on it. So I'm going to go with the on facing me, and when I do that, it's going to start cutting through the surface. So one thing, if you try to hold this box, it's going to start sliding around on you if you're pulling on a lateral plane. So you don't want that. You want to put it on a longitudinal plane. And usually I will kneel down on it and I'll start cranking like that. But by putting all of your weight on it, you're controlling this thing from sliding around, and it helps give you a little bit more leverage when you're pushing downward. Some people like to try to pull. That's okay too, but it ends up just straining your wrist and you don't have as much strength. So I find that pushing, going all the way back and pushing, that's the best way to go about it. It starts to get hard after a while, especially if your dies are not sharp. You'll know. Alright, so now just put that in there. Lock ring on, and voila, done. So that is the manual method with the hand knockout set. Next thing we're going to talk about is the hydraulic knockout set. Now, hydraulic knockout set has been the big savior for many years for not having to do hand knockouts, especially if you're doing like 2.5, 3-inch, 4-inch stuff like that. Having a hydraulic set is great. You can see that it's just the same thing essentially. You still have to knock out a hole in the center, you still have to line everything up, you put a die in, you put the cup in, but you're hand pumping this hydraulic pump. These things are great. They're super durable. I mean, they last many years as long as you keep up with the hydraulic fluid in them. The way that the tool releases and catches is by this little knob on the side, and once you tighten this knob or loosen this knob, it releases the die from the cup, or it allows the die and the cup to be tightened together. But the whole thing works off hydraulic pressure. So these things are really great. They're very expensive, but they're strong tools and they'll last you a really long time. The last method that we're going to talk about is using this Force Logic M18 knockout set. It's battery operated. It's on the M18 system. This is a smaller battery than I normally use. Usually I would use like a 5.0 or something like that. But this is really neat because you don't have to do any of the work. Everything is done for you. I also like just, they've got extra grip on all of the edges of their dies. And the cups have lines on them, and that helps out tremendously. If you've got a line that you know on here that you've measured out, these lines on the side, they're really easy to see, the little red line. So you just line up the red line on that side, line it up on that side, and you know that you're in the center. So that's just really like a really cool idea. Or you can mark off to the side, you know, if you're trying to find center and you need to get a straight edge and figure out where center is. Just having the lines there is like super helpful. So I'm gonna do the same thing. Just cut the middle out. And this we're going to be doing a 2-inch. Again, this is 2-inch conduit. That's not saying that this is 2 inches. So we just pop this on there. Make sure that all of our lines are lined up. This is really handy if you over drill your holes. A lot of people will drill, you know, too big of a hole, and then this thing moves around a lot, so you can't really tell if you're on the line. But the fact that these actually have these red lines on it means that you're guaranteed to hit every time. So we just pull the trigger. You got to make sure that it's down. This is what releases it. So I'm just going to hit the trigger. Watch this. Like butter. Like nothing. Done. Then you hit this little button, releases it, and you're ready for the next one. Now, the other cool thing about this tool is that there's a different way that you can set it up. So instead of having this thing on there, you can have this on here. And it allows for a little ball to go in there, which is what this is. So if I wanted to do that same cut, instead of having to have the tool on there, I can just handle this independently. So I can do like this. And then it comes with this special little adapter. This locks in place, and it lets you slide over that ball and pull the trigger. Same thing. Boom. So just a different method, but then that allows you to slide this ball out and just keep going down the line if you prefer to be able to do that rather than having it attached to the tool this whole time with this pin on it. It's just different methods of doing it, different ways that you can use the tool. So now that we just got our 2-inch holes knocked out, put our connector in, and voila. So sometimes you'll see people do multiple rows, and what you want to try to do is get everything in a straight line and make it really pretty. Obviously, I'm just using this as a fun thing. The other really cool thing that I think is worth talking about is that there are bigger dies. This is a 2.5, 3-inch, 3.5, and a 4-inch. So 4-inch, trying to hand crank one of these 4 inches is really extremely difficult. Damn near impossible sometimes. All right, so you notice there's a bigger hole on these two than there is on these other ones. So we have to get this in the tool. And then just like we did before, it's gonna go on like that. So let's get a hole set up. This one you gotta drill a little bit bigger hole. So I can't just use this regular 1/2 inch, I gotta step up a size. All right, so that's my 3/4. Anytime you're using a carbide bit, you don't want to heat the bit up too much. I'm drilling a little faster than I normally would just because it's hot and I'm trying to get things done. want to take care of your carbide bits and drill slow, or use some kind of cutting oil or something to like decrease the temperature. All right, so this is a 4-inch hole. That is a beast. Let's see how he works. Look at that. Cutting through like nothing. No resistance whatsoever. Done. This thing is my favorite tool. Like bar none, this is my favorite.
All right, thank you guys so much for watching. I hope that helped a few of you guys out. If you're interested at all in learning more about the Milwaukee Grid program, there's a link in the description below. Again, it's just like a whole bunch of different resources. Like when I was an apprentice, just anything that I could do to find extra videos about stuff about how to use tools and how electricity works and all of that stuff, I found it really useful. So click the link in the description below, go visit the Milwaukee Grid program, and that's pretty much it. Join the channel. You get all kinds of like membership benefits if you join. If you're a 1,000-volt member, you actually get to text with me if you have any questions about how electricity works. 480-volt membership, you get your name up on the screen like all of these cool guys and gals. Sorry. But make sure that you hit the little bell that lets you know every time I've got a video coming out. Like this video, please subscribe if you love the channel, and I will see you in the next one.
Best music and video.